Hello, you're very welcome to this special event to mark the publication of Catching the Worm, which is the memoir of Professor William C. Campbell and is published by the Royal Irish Academy in partnership with the RDS. Now, we had lots of lovely plans to launch this book, but then along came COVID-19 and we had to come up with other plans. But coronavirus is the mother of invention, so instead of bringing Bill over from the United States to Ireland for the launch, we are beaming him in virtually for a conversation with another famous Irish scientist, Professor Luke O'Neill. So one of the big things that happened to Bill in the last few years is that he won a Nobel Prize in physiology or medicine. And he won this prize for his work on a medicine called Ivermectin, which has had a huge impact on global health, not only because it has been used in agriculture, in livestock, to combat parasites, but it has also had a huge impact on human health because of its use to combat a parasitic disease called river blindness. And over the years, ivermectin has spared millions of people around the world from the debilitating effects of this awful disease. Bill is the only scientist from Ireland to have a Nobel Prize in physiology or medicine. He is from Ramelton in County Donegal, and he studied in Trinity College Dublin before moving to the United States to do his PhD in the University of Wisconsin-Madison, and then he went to work with Merck. Luke is an immunologist, and he's professor of biochemistry at Trinity College Dublin, and he has long been a familiar face in Irish media, and all the more so since COVID-19 came to town. Luke has won the Royal Dublin Society Irish Times Boyle Medal for Scientific Excellence and the Royal Irish Academy Gold Medal for Life Sciences, and he has made key discoveries about how our immune systems work. So today, what's today about? Well, my name is Claire O'Connell, and I wrote Catching the Worm with Bill. We worked on it together. And I can barely believe it. It's an actual book now, Bill. Isn't that amazing? And we're publishing it on the occasion of Bill's 90th birthday. So happy birthday, Bill. And how are you celebrating the big day?
Well, it's a wonderful day, as it happens. It's certainly not the way I expected to spend the day. I was hoping to be in Ireland, and I'm very disappointed that I'm not. But on the other hand, it's a wonderful time of togetherness because thanks to modern technology, we can still get together, mostly in a hugless way, but a wonderful way. And so it's a time of phone calls and special phone calls through technology that lets us see each other. And then the very special thing is that we're expecting momentarily, so to speak, a visit from our daughter Betsy and her family, which includes our 3 youngest grandchildren. And that will be outdoors on the lawn. There'll be cake, but disposable plates, disposable cups, and it will be absolutely wonderful. It's the first time we've actually seen each other in real life for months because of the lockdown. So that's going to be great, and that's another part of this celebration.
Well, that sounds like a wonderful way to celebrate your birthday, catching up after so many months apart. Luke, how has lockdown been for you?
Good question, Claire. I read the book, by the way, but it's a great book. I really enjoyed it. That was one thing I could do, yeah. Well, it's been tricky for us all, hasn't it? It's amazing. We're coming out of it now slowly, which is great. Good to hear you're coming out of it as well, Bill, because the world is reopening now, isn't it, in many ways? So let's hope we get back to normal. If we can beat this virus, of course. And for science, it's been a fantastic time,
yes,
by the way, because scientists have stepped up, and virologists and immunologists and everybody doing their best to beat this virus. So it's been a huge adventure as well, I guess.
Great. Well, Bill, let's talk about worms, because you're a parasitologist and your interest is in parasitic worms. And I suppose when most people think of worms, they think of the wriggly things that you find when you dig the garden or you dig a field. But you're interested in kind of the wider world of worms. Can you explain that to us?
Well, I think worms are just wonderful folk. I mean, they are amazing. First of all, in their appearance, which we don't see usually, but with microscopes and things, we can have a look at them. And they have incredible structural diversity. So to me, they're sort of like a whole new garden of worms. They're sort of an inexhaustible garden of worms because we're discovering new ones every day. And they have a fantastic variety They're all colorless, but they have great variety of structure. And the other thing is that they're absolutely brilliant. Now, they're not brilliant in the way that we think of people being brilliant. So it's more a case of nature, of the whole system being brilliant. And for example, they have these incredible life cycles, which are absolutely mind-boggling. And well, a good example would be the common liver fluke, which I know happens in Ireland to sheep and cattle. And that fluke spends part of its life in sheep or cattle, and part of its life on the outdoors, and then part of its life in the snail, and then part of its life outdoors again, and then back into sheep or cattle. But that's really nothing compared to a close relative, the lancet fluke, which spends part of its time outdoors and in snails, but then part of its time in the body of ants, and then gets back into sheep and cattle. And not only does it spend time in ants, but it does a most incredible thing while it's in the ants. It actually, the baby stage of the worm actually gets into the brain of an ant. Now, you might not think there's much brain to get into in an ant, but there is a brain in an ant. And these microscopic worms get into the ant's brain and cause it to change its behavior, which it doesn't want to do, but it's forced by the worm to change its behavior to make it more likely that it will be eaten by a sheep or a calf, and so on. So that's the sort of thing that is just, I mean, no human poet or novelist or philosopher could dream up such a thing. And yet here we have it happening every day all around us, because parasites are all around us. It's the most common form of life, of the life system. And so I could just go on and on, but you get the idea that I really, really think they're wonderful people, the parasites.
And of course, one of the lines in the book, Bill, is that you love worms, and it's obvious that you do. You're fascinated by them, but you spent a lot of your career trying to kill them, because some parasitic worms are ones that really cause a lot of suffering and economic damage. So maybe you could talk to us a little bit about the discovery of ivermectin, which was just one of the drugs that you worked on, but one of the most successful ones, I suppose, that came out of that time. Can you tell us how that drug was discovered?
Well, yes, unfortunately, while the worms are wonderful, they certainly do things that are not wonderful, and we are often the victims, and our livestock or domestic animals are victims, and our companion animals are victims. And so something has to be done about it. So yes, I've been trying to get rid of them, much though I hate to do it. It's really not their fault, of course, that they do these terrible things. It's just they're doing their thing and we're doing our thing, and they don't always get along together. So in the case of ivermectin, this antiparasitic drug, it was discovered. And I don't know if you want to hear about the discovery now, or no, you were asking about the disease, mainly, the river blindness. And river blindness is caused by a worm. It's a roundworm, and it belongs to a group of roundworms known as filarial worms, which are very long, thin, spaghetti-like worms. And they get to a big size. They can get to a foot and a half long. And they live in people and only in people. And the trouble is that while they're in our bodies, and they're mostly just under the skin, they reproduce, so they have their babies, so to speak. They have their progeny. And those baby worms, which are called microfilariae, they get out into the skin, not on the outer surface of the skin, but in the tissue of the skin itself, and they migrate all over the body. And they cause a horrendous dermatological disease with depigmentation, and especially with a horrendous itch that drives people absolutely crazy. So the itch and the skin damage can be very disfiguring, and you lose the elasticity of your skin so that you have young people who look like old people. And then the worst part of it is that some of those baby worms get into the eyes and make people blind. And that in itself is a bit complicated and involves bacteria and an immunological response. But the bottom line is that it causes people to go blind. So it's a very serious disease, has been affecting millions of people for a very long time. So that's the disease. It occurs in the tropics, in large parts of Africa, a little bit of the Middle East, and a large part of Central and South America.
The discovery, or you and your team had made the discovery that ivermectin can work against parasites, and originally that was applied in agriculture mostly. What prompted you to try ivermectin against river blindness in humans?
Well, there are several things. You say it was being widely used in domestic animals to control parasitic diseases, and some of those diseases are caused by different kinds of worm parasites. And I happened to spend some time working on a parasite of dogs called Dirophilaria immitis, which causes heartworm disease in dogs and causes apparently healthy dogs to suddenly drop dead after exercise. So it's not a common thing in Ireland because it's transmitted by mosquitoes, and Ireland is not ideal really for mosquitoes, and mosquitoes are a good thing not to have around. But in countries that have a lot of mosquitoes, you have the heartworm of dogs. So this happens to be caused by this kind of roundworm that I mentioned called a filarial worm. So I had an opportunity to set up a program on heartworm disease, and with my colleagues, we found that ivermectin, this new drug, was highly effective, not only in sort of destroying the worm, but in highly effective in a way that allowed us to develop a preventive treatment, not a cure, but a preventive. And a preventive that needs to be given only once a month instead of once a day, which had been the custom. So this was a thing that was very close to me. And the other thing was that I was at that time giving a series of lectures every autumn in a medical school on human parasites. So I was pretty much aware of what diseases had good cures and what ones had bad ones. And I had traveled in South America and seen these diseases for myself. So I was very much attuned to human parasites, even though our drug was mainly being used in domestic animals. So those things played a picture. And also my colleagues in the parasitology department at Merck and Company were testing the drug against a great variety of parasites, including filarial parasites in horses, and then by collaboration with colleague in Australia, cattle. So we realized that this could actually apply to the filarial worm disease of people. And so I suggested that this had potential to cure river blindness in particular. And so I got people interested in it in the company, and became more and more interesting, and it was decided that yes, it had to be tried in humans, which is certainly not a small thing to do, and so that's quite complicated. But it was tried and it worked in humans, so that expanded, and then a lot of other people and agencies were brought in, and so it was because of all these other agencies and because Merck made a decision to donate the drug, that really had a huge impact because then it became possible to distribute this drug with great difficulty, mind you, into very remote villages where river blindness occurred. and so it has had an effect. And when I say it occurs in South America, it in fact is almost being eliminated from South America. There's just one little tiny area where it exists, but in 4 countries it has been completely eliminated. So that is how that came about.
It's an absolutely amazing story of how a scientific discovery can have such a huge impact on human health and human lives. And when you talk about a disease practically being eliminated in parts of the world and the burden of suffering being massively reduced, that's absolutely incredible. And it was for this work that you received the Nobel Prize. But before we talk about that, ivermectin has been back in the news recently because it does seem to kill a certain coronavirus, namely SARS-CoV-2, which is the virus that causes COVID-19. So Luke, what are your thoughts on that?
Well, indeed. By the way, happy birthday, Bill, is the first thing I would say. And it's a great pleasure to talk to you. And I'm honoured to be here with you, actually. Not virtually here with you, of course. You must be surprised about the COVID-19 development, Bill, aren't you? Because who saw that coming? It's incredible, isn't it? You know. And I guess no more than any, in your book, by the way, I do see a great quote that the greatest ally to science is doubt. Isn't that right? Or you've got some line like that. And you have said, look, it's a very high dose and there's various issues. But it's striking, isn't it? That Australian lab has shown it can kill COVID-2. I mean, it's incredible. So
this was basically a researcher in Australia who applied the drug to cells that had been infected with the virus, and it found that the ivermectin could stop the virus from basically establishing an infection in those cells. Now that's an experiment that took place in a lab. But what's exciting now is that there are clinical trials in humans underway to see could this drug be part of sort of a suite of drugs that we use against the virus.
Exactly, but it's a very safe drug, right, Bill, first of all. So the trial will not have a safety signal, you would hope, and it's well worth a shot. I think you would agree. Give it a go because it's a safe drug. There's evidence in vitro, obviously limitations, but still it's worth trying, isn't it? But I've got a question, Bill, actually, in terms of mechanism of action. You know, ivermectin blocks these chloride channels, right? Isn't that its main mechanism, I believe, in the worm? So I'm wondering what its mechanism might be in COVID-19. Have you any ideas about how it would work against that virus, say, compared to how it works in worms?
It affects the chloride ion channel receptor, a domesticated receptor, and causes paralysis in worms, and then the worms die. But as far as the virus is concerned, they think it's probably something different, like affecting the importation of RNA into a nucleus and so on. So, but that remains to be seen. But as you say, trials are underway. But one of the things we have to be very careful about now is that because it is safe and because it's approved for certain uses, there's a tremendous inclination and temptation for practitioners who confront patients to try it. And so we're already having a lot of scattered observations made in an uncontrolled way. And that is causing hopes to be raised, perhaps prematurely. And so it's very important that studies are being done that will be controlled studies. And so I just make that as a cautionary remark, because it's almost impossible to keep people from just having a go, as Luke says.
Exactly. Bill, go back slightly. I mean, your attraction to worms in the first place. Have you seen the movie Alien, when this creature jumps out of John Hurt's chest? You know, so most people find worms obnoxious, shall we say, and rather sickening creatures that kind of slither, you know, and wreck your liver or wreck your brain or whatever it might be. What drew you to them from that? Was it purely scientific, or did you like their beauty as well? You know, and I know you paint them. You're a great artist and you have great paintings of worms. But to most people, worms are to be, you know, they're repulsive creatures, aren't they? Now, I'm not saying life should be considered repulsive. We love all life, don't we? But I'm intrigued by your love of them, really.
Yeah, well, that's true. But you have to get to know them to like them. I mean, that's the thing. Most people don't know them, and they sort of just think of them. And it's all very unfair, this reputation that they have. And people think that they're sort of shy and obnoxious. And as I say, it's totally unfair, because the worms are just doing their thing. But you need to get to know them and see them through a microscope and to see how wonderful they are and to see a tapeworm live under a dissecting scope with its sort of pulsating, it's just pulsating effect and its little hooklets first grabbing onto the inside lining of your intestine. It's just, and they're so creative. It's just amazing. So you have to get to know them, and you have to get to appreciate the fact that they're not intentionally going to get you.
Do you consider this to be a beautiful thing? Because some of your paintings are certainly beautiful, and I guess you must see beauty in them as well as scientific wonder.
Yes. Well, I think I try to give them a helping hand by adding color, for example.
Yeah, that's right.
So they lack color, so I give them a lot of color. And so maybe it's gilding the lily, but still that's what I love to do. So I think they look great.
Very good. Speaking of colour, it would be great to hear from you, Bill, about the Nobel Prize, because this is something you won in 2015. And tell us how you found out about that this had happened.
Well, I learned it the hard way by being waking up early in the morning with a phone call. Not the famous phone call that people get from Stockholm, but from one of the major news agencies who had got wind of this and telephoned me very early and said I had got a Nobel Prize, and I remember saying, "You've got to be kidding." And he said, this reporter said, "Well, just go to Nobel.org and check it out," which I did while I was still on the phone, and it was true apparently. So that was a short, unexpected call, and followed very shortly after by the call from the Nobel organization confirming it. And this was in November 2015. And toward the end of the conversation, the Nobel representative said, "We would like to see you in Stockholm in December." And I said, "You mean December 2016? And he said, "No, 2015. Well, that was only a few weeks away. And so that was, that not only changed everything, but changed it very quickly. And there you see the final phase of it, which is just one part of it. And it's a week long, which I hadn't never realized. In fact, it was 8 days in case where Mary, my wife, and I were there with a lot of our family. A fantastic and fabulous occasion. And there's Mary and me on that occasion in our finery. And that was a big part of it, was the finery, because especially for my wife, her first reaction on hearing this news was, "But I have nothing to wear." And she says herself that this was her first concern. But anyway, fortunately she came through with a beautiful evening gown. And my problem was not what to wear, but how to get into that outfit. But the Nobel people do everything possible to make things easy.
You were really there for about a week. You and Mary were going to parties, and this is what I mean by the colour of it all. It was like a big whirlwind, wasn't it?
In terms of pomp and circumstance, this must be just really it. It's the height of pomp and circumstance. And you have these fantastic banquets, not just the royal banquet, but certainly the royal banquet is part of it. And the fantastic concerts and events, lectures. You give a Nobel, you're obliged to give a Nobel lecture, and then a few laureates also give speeches during the banquet, and it fell to my lot to give one of those. So there's a lot going on, and very, very exciting, I must say. But I also should say But in the lead up to it, there was another big unforgettable event, and that was going to the White House to meet the President of the United States. And that was very special. That applied just to the 4 American laureates of that year, because I had become an American citizen. And we went to the White House through arrangements with the Swedish and Norwegian embassies, who also had great parties and dinners for us. But at the White House, we had a chance to meet President Obama in the Oval Office. And when Mary and I first went in and were talking to him in the Oval Office, the president really stunned me by reaching into his jacket pocket and bringing out a little stuffed animal, which you can see in the picture, which is actually a representation of a dog heartworm. And it has a little heart embroidered on top of it, and it has a little label saying heartworm. And to have the President of the United States just come out of the blue with this thing from his pocket was an amazing thing. And he talked to me about my work on canine heartworm disease. And so, and then later on in it with the other laureates, we had a great time. He was in a very friendly, jovial mood, making jokes and getting serious, and we had a wonderful visit with him. And the reason that I particularly want to mention it is because of the consequences of these two things. Because I give a lot of talks to students, high school level, college level, often to underprivileged students from inner cities, a lot of African American minority students. And I show them pictures of meeting President Obama, and also picture meeting the King and Queen. And it's interesting because to them, they can really relate to the president. And it's a moving thing to see their reaction.
That's
Okay.
lovely. That's lovely, Bill, and very well deserved as well. I mean, it's wonderful that the discovery was so highly celebrated, the discovery of ivermectin, and of course you shared that part of the prize with Satoshi Umuru. Maybe you could talk to us a little bit about how that discovery came about initially of, first of all, ivermectin, which was kind of like almost like the parent compound, and it came from, originally it came from a soil sample in a plastic bag, isn't that right?
Yes, that's very important. I'm glad you brought that up, because the process of discovery is a whole thing in itself, it's a whole topic. And I'll see if I can be somewhat concise about it. But the thing that was the thing that had characterized this discovery was that it was both traditional and innovative. It was traditional in the sense that we went about it in the old-fashioned way of looking for drugs, trying to find them by trial and error, rather than trying to design them or create them as entirely novel entities. So it was traditional in that sense. And in that sense, we tried to maximize our chances to find something by arranging for people in various parts of the world to send us samples of microbes that they would isolate from many places, including soil, in fact, mostly from soil in different parts of the world. And this was because of the great heritage of penicillin and then subsequently other antibiotics, which were produced by microorganisms, mainly by bacteria. And so we were getting bacteria sent to us. And when we would try and find among those bacteria one that would produce something new, and something new that would kill worms. And so one of the people who were sending us microorganisms were the people at the Kitasato Institute in Japan, and in particular Professor Satoshi Omura. And we had an arrangement with Professor Omura for him to send us samples, and he sent us samples that were a bit out of the ordinary, which of course is what we wanted. We didn't want to keep rediscovering things that were already known. So among the ones that he sent us was a microorganism that produced a novel substance that killed worm parasites. And so the innovative part of this discovery, as opposed to the traditional, was that we looked for them in a way that other people had not been looking for them. People had been looking for antibacterial agents by looking at different kinds of microbes, but they had not been looking for anti-worm agents because of methodological differences. There was sort of an impasse because you can't just grow worms up in test tubes the way you can grow bacteria. So there's a methodological impasse there, which we overcame by an innovative assay, a testing method that was novel. And so it was also a testing method that made it very unlikely we would have any success in finding an agent unless it was a very powerful agent. Well, that's exactly what happened. We did find one, and it was a very powerful agent, and it was from one of Professor Omura's bacteria. And we described the bacterium, and we discovered this activity, and our chemists discovered what it was that the bacterium was producing that caused worms to die. And the microbiologists discovered ways to make this microorganism produce more of it, and so on. So more scientific disciplines came into the picture and embarked on this great developmental process then following the initial discovery.
Do we know why Streptomyces makes it? So the bacteria must be making it for some reason. Is it to kill off a worm itself, or is it to kill something else?
It is a species of streptomycin, but it makes very different things than other species of streptomycin. But as to why it does that, well, one is tempting to think that when it lives in the soil, it's surrounded by all other microorganisms and with with free living worms, microscopic worms. And it's tempting to think that it's doing that to defend itself against these microscopic worms, which live in great abundance in the soil. However, we don't know that. And in fact, in most of these cases, we don't know that, but we know that it produces something in the laboratory that will kill worms in the laboratory. Well, it also kills them not in animals. But we don't know at all why bacterium produces.
But you don't need to know necessarily, you know.
Well, that's a very important point that we don't need to know.
Yeah.
And in fact, we don't even need to know biochemically, and you may not like this, Luke, we don't even know why it works biochemically to kill worms in animals.
Absolutely.
But, of course, eventually we have an obligation to find out. But anyway, that's another role.
Onchocerca, which is the river blindness worm, was just one of many parasitic worms that you worked on. So can you tell us about a couple of the other worms that have crossed your path, scientifically speaking, over the years?
Right. Yeah, I've been incredibly lucky because you don't really count, even if you're in the business of experimental chemotherapy, you don't really count on a hit. I mean, because there is so much chance involved in it, especially if you do it the old-fashioned way, which is built on chance intentionally and designed to exploit chance, which is another part of my whole thing about the process of discovery. So I feel very lucky that I've been involved in several of these. One that might mean most to many people would be connected with liver fluke, because I was interested in liver fluke just because that's one of the things I learned about very on. And also for my graduate work, for my PhD thesis, I worked on a giant American liver fluke, which is a cousin of the one that occurs worldwide. So I had an interest in liver fluke, and it was not why I went to Merck. But later on during my career, I set up a liver fluke program and looked with the help of the chemists at Merck to look for a chemical that would kill liver fluke. And we were very lucky in finding one. And a lot of other people around the world were also looking for them and discovering them. So there were several compounds developing for treating liver fluke. And each one sort of in turn has its best. It gets on the market and makes a niche for itself because it's the best. And then eventually another one comes along and then it's the best and so on. But we had actually two of such worms that went onto the market and became successful in controlling liver fluke in sheep and cattle. So that was an amazing thing. And then there was ivermectin for canine heartworm. And then there was another compound that was related to thiabendazole, which had been a major blockbuster antiparasitic agent that had come from the Merck labs when I was just starting there. And then we had another one called cambendazole and so on. But one thing I should mention, just to put it in perspective, is that I actually went to Merck to work on a worm called schistosoma, which causes a human parasitic disease, schistosomiasis or bilharziosis. And I worked on that exclusively for 7 years, and I had an absolutely unbroken record of failure. And I had a great time doing it, and I was prepared to go on doing it for the rest of my life, because I said, you accept failure. Yeah. It's sort of the opposite of the space program, where they say failure is not an option. In this business, failure is almost the default position. So I was not the slightest bit disheartened. And we didn't, because we had a great time scientifically for those years. And that program continued after I was no longer responsible just for that program. But so I spent 7 years just on that. And we did actually discover a great compound that would kill schistosomes earlier and better and safer than anything available. However, although it was safer in a sort of acute sense, grossly safe, it actually was not safe enough. It would be likely to cause people to get severe sunburn, for example, because it would induce a photosensitivity. So that was ruled out. So nevertheless, it was incredibly exciting to make that discovery and have it tested and have the prospect that it might actually work in people, for millions of people. But the fact that it didn't wasn't any sort of crushing blow or anything remotely like that. It was just, that's what we do.
One of the things that I think has come across in the book is that by working on all those different things, Bill, it puts you in a position to be able to see links between things, whether that's parasites in animals versus humans, or what might affect one worm or another worm. That kind of cross-linkage of information is very important for scientists. Is that something that you do, Luke, in your line of work? I mean, immunology is a very complex field, so how do you cope with that?
It's very difficult, actually, Claire, because I think Bill is absolutely right when he says that chance is the key thing, isn't it, Bill? In other words, it's very hard to make these discoveries at the best of times, And in my opinion, Bill, drug discovery is the most difficult thing we can do, actually. Like the moonshot was easy, wasn't it? You get to the last step and you fail, and so many examples of drugs, like Bill's example, toxic in humans, unexpected. You couldn't have predicted that, So you need to be very clever. At least you need to be clever as you can be, I suppose, and link things together in various ways. And I think, Bill, what you said that was really compelling for me was the empirical approach seems to be a key aspect, right? And you seemed, I wouldn't say critical of, but certainly more questioning of the more targeted approach that drug companies use nowadays. I wonder, could you talk about that a bit? Because everybody's doing targeted therapies, aren't they now? And you feel the sort of loss of the empirical angle is a negative, isn't it? Wasn't that your view overall? Because if you'd taken the targeted approach, you never have found ivermectin, would you? You never have found it because you didn't know what you were looking for, you know?
We would not have found it, no. And I hesitate in a way to talk about it because I have felt so strongly for so many years, decades.
Yeah.
But yes, I think we should not give up on the empirical approach. And I know when ivermectin was first making headlines scientifically, I had a friend, a biochemist in the university, and he used to show the structure once it was discovered on the screen to his class and remind them, his biochemical students, that they never would have made that compound. I mean, it just wasn't going to happen.
Exactly.
So it would not have been discovered the other way. And of course, we had no idea about the mode of action then, so they would not have been discovered by setting up assays to look at the glutamate receptor because that wasn't known. But also, even then, there's a downside to that because if you take the mode of action of a known compound and use that as a basis for looking to new ones, you tend to find something that may be chemically different but may tend to share cross-resistance and may have enough in common that you share some of the downside that is making the other compound obsolete.
Yeah.
So it's,
Exactly, yeah. I think it's worth emphasizing, Bill, as well, if there had been a Nobel Prize for veterinary medicine, you would have won that one as well. Because the impact on veterinary medicine was huge, wasn't it, Bill? I mean, I think in the book you say it was the third best-selling drug of any veterinary medicine. Isn't that right, ivermectin? So the contribution ivermectin has made to agriculture is probably more than human disease, is it overall? Now, obviously, we want to help humans, of course we do, but just the economic impact on the agricultural sector must have been pretty big as well, was it?
It is vastly greater, yes, absolutely. And if you look at it in the terms of the production of food and fiber in agriculture being for human benefit, you could say that also the use in agriculture was an added benefit to humans.
Anyway, yeah.
So, but yes, in agriculture, it was huge, and even just the dog program for dog heartworm. I mean, it may say something about us as humans as a species, but that compound alone is said to have made the Merck agricultural branch called AgChem the biggest. Not called AgChem, it was whatever it was called. MSD AgVet, I guess, was the biggest animal health company for a while. So yeah, it had a huge economic impact.
Yeah. And even beyond that, Bill, I mean, dog owners would love you too, because the suffering of dogs through heartworm was a serious veterinary problem, wasn't it? And that ivermectin came along and gets rid of that disease in dogs as well. So humans benefit through that mechanism too, I guess.
Well, horse lovers stay even more because they had their own problems, and now they were suddenly that was the solution. Yeah,
the Irish nation love horses, as you know, Bill, so they're very grateful to you for helping the horse industry. Well, is there any industry you haven't helped? I'm wondering at this stage.
I suppose it's interesting that it's come back to agriculture, because Bill, you grew up in Ramelton in County Donegal, and your father was a very important person for the farmers in the region because he ran the local shop where they got supplies, your father pretty much sold everything they needed. And can you tell us about that? Can you tell us about your youth in County Donegal?
Right, well certainly that's one of my father's specialties of his shop, in fact, was farm implements. And I remember growing up, because we grew up on the main street, just on one side of the river. And, well, there's a picture of it, in fact. And when I was growing up, and that's sort of got a modern face, and it was not quite such a fancy shop. But when I was growing up, the parts, instead of having cars that were lined along the street, you'd have on the side of the street, right in front of the shop, reapers. and hay racks and plows and all kinds of farm. And they were dragged out every day. In fact, we often as kids would get to help dragging those things back to the back of the shop at night time and putting them out again in the morning. So agricultural implements were the big thing, and also he was big on potatoes, also not only big on growing them and eating them in season, different varieties. He was very, very big on potatoes at the dinner table, but also in buying them from farmers and selling them and exporting them around the world. And also grass seed was another of things he would do. So yes, there was a big connection with the surrounding farm community.
And of course, your house where you lived was pretty much kind of attached to the shop. And it's also where you went to school as a child, isn't it? You went to school in the attic where a tutor taught yourself and your siblings.
That's right, yes. We were not homeschooled in the American sense where your parents teach the children. But we were homeschooled in the sense that when I went to school, I went upstairs to the attic. So, and my brothers and my sister, we all did that. And I think I was very lucky in that. I suppose there was a downside, there usually is, in terms of social interactions by going to school in your own home. But in my case, it was the teacher that made a difference, because we had a tutor who was a qualified teacher, and she had us as her only pupils, and at times I was the only pupil. So she was, to my mind, really great looking back. I mean, I suppose I didn't appreciate it at the time. But she just conveyed this sense of feeling good about knowing something, not because you feel any better, but because it's so satisfying to know something today that you didn't know yesterday. And just because when you're very young, as you know, everything is interesting. So she had exposed me to more things to be interested in. So she was absolutely, I think, a key person in my education.
What I find very interesting about that is that throughout that, I know you did a lot of things like English and Latin, you never learned science at that stage. It was only when you went to secondary school at Campbell College that you developed an interest, you even kind of learned that there was such a thing as science, and your biology teacher was kind of maybe took over from that, from the tutor, Miss Martin, in terms of inspiring that love of a subject in you. Is that right?
That's absolutely right. She knew nothing about science. I don't know whether she must have heard of science, but she certainly never mentioned it. This tutor, Miss Martin, she was a wonderful, wonderful person, and lived with us also, and got along well with my mother and my father. But she never mentioned science at all. So when I went to secondary school, to high school level, to a boarding school, that was a really rude awakening, and it was very difficult for me, in fact. In fact, the physics and chemistry was always, and still always, totally mystifying to me, but the biology teacher who rescued me that captured my interest, and so that I was able to sneak by in terms of physics and chemistry and concentrate on biology.
Is it true, Bill, you were assessed at some point and said, don't do science or something? There was some aptitude test or something that said you shouldn't be going in. Isn't that marvellous? Don't do science and he wins the Nobel Prize. Isn't that fantastic?
That happened much later in life, absolutely.
Yeah.
Yes, when I was in mid-career, and with some other people, we went to this famous aptitude testing thing in New York City, and they did all kinds of tests. And the bottom line was that I should be into things that are related to people and literature and stuff, and stay away from science.
Can I ask, along the same lines, what do you think is the biggest challenge in parasitology today? Is malaria still the big one to beat?
The biggest, which is incredible, considering how long it has been around,
Yeah.
as you well know, and what incredibly great work has been done in immunology of malaria, which, as you well know, and also just endless research forever on malaria and promising developments all the time, and yet it hangs on there.
Yep.
And of course, now with climate warming, there's actually ways in which it's getting worse rather than better. So it's, malaria is certainly the big challenge.
And Bill, have you got faith that the pharmaceutical industry is still interested in these diseases? Clearly, they still work on them, of course they do, but the heat went out a bit, didn't it? And they began to do less, and also to do with any kind of infectious disease, really. Of course, COVID-19 might change all that. Do you think the pharma sector is still fully on board?
No, I think that has changed. And to my mind and the mind of many of us, the whole turning away from natural product science has been a tremendous loss, and most pharmaceutical companies have sort of given up their natural products research departments,
Yep.
Which used to be a source of not just plants as we normally think of it, but bacteria, for example. And so, as sources of novel products, there has been a lot less interest now than there used to be. And of course, to my mind, the dominance of molecular biology meant a certain amount of exclusion of old-fashioned stuff that I don't think should be obsolete.
Yes. No,
Do you think that the COVID-19 pandemic will change any of that? Do you think people will start to look for things in new ways now because of this? We've already seen a lot more collaboration across science, which you might not have thought would have happened, but it has happened organically, for want of a better word, in this crisis. Do you think that things might change in science from now on?
Yeah, I think there will be some changes, and certainly the collaboration aspect of it will be boosted. But I also would take the opportunity to point out that the ivermectin and river blindness phenomenon already broke open new ground, and with agencies such as the Bill and Melinda Gates Foundation and so on, there has been a tremendous collaboration between the private sector and the commercial sector that didn't exist before, partly for sound reasons relating to patents and things, but that whole thing has been broken open, and it's been demonstrated that you don't have to ruin the basic economic system in order to collaborate. And so there is much more collaboration than there used to be even before COVID. But certainly the COVID-19 pandemic is a boost in that direction also.
To finish up, are there any insights that you both have, Bill and Luke, that you could pass on to younger scientists maybe starting out in their careers now, be that in academia or industry? What pieces of advice would you give to them now?
Well, I'm sure Luke, being a younger scientist himself, will have lots of good things to say. I don't have sort of answers. I do think that one of the keys for young scientists is to sort of remember the basics of industriousness and intellectual honesty and curiosity. I think, without any trimmings, those will always be a foundation. And for me, looking back, I have come to realize how much scientific research is or can be an adventure. It's a matter of exploration. And I don't think I realized how much that was true while I was having a career. You don't really realize you have a career until you realize you suddenly had it. But I think the thing about exploration is important, that you have a sort of drive to find out something new and also to be the first to do something. I think that's perfectly valid as a motivator. I think we sort of have that in ourselves. And I used to worry and think that maybe that was an essential element of vanity. But then I discovered that vanity is always unnecessarily excessive pride. And that's certainly not what I would be in favor of. But I think it's certainly a good thing for a person to want to do something that hasn't been done before and to be the person who does the thing that has. I think those things go together. So I think one should look at those sort of things.
But Claire, first of all, Bill, I would recommend your book to every young scientist or even young person in secondary school. They should read your book because it's a great story, first of all, from start to finish. And then you do actually give little tidbits of advice, you know. There's Bill Campbell's top 5 tips or whatever, but maybe when it's reprinted, Claire, you list them. One was keep good notes. I remember that one, Bill. Keep a good lab book. That was a key one you said, and for example. But I also think, touching on more broadly what Bill is saying, young people want a mission. They want to say, I'm on a mission to do something. It could be climate change. It could be parasitology. It could be COVID-19. I mean, one thing COVID-19's taught me is they all want to do immunology now. Oh, fantastic. Let's get on a mission. So pick your mission carefully and get on with it, and then use rigor and be prepared for disappointment, Bill. Wouldn't you agree, as you said with your sister's own story, 7 years and nothing didn't put you off, did it? Keep going. Just keep the head down and keep going. You get somewhere. And if the mission is strong enough, you may make it. You never know. You might have to make a contribution.
Fantastic. And just before we wrap up, I just wanted to give a reminder of the kind of impact that good science and the work that Bill and colleagues did on parasitology to develop ivermectin has had. So we have, thanks to Sight Savers Ireland, this image of Mamodu in Asubende in Ghana, who lost his sight in his 40s because of river blindness, and he's wholly reliant on his nephew. But the good news is that the next generation of his family, including his nephew, will not suffer the debilitating effects of this disease. And let's also celebrate the volunteers who distribute ivermectin to their communities. This is Mary Bachokiri, also in Asubende in Ghana, and she's making sure everyone gets the dose they need. And you can see the dose pole there in the background, where they use the dose pole to figure out the height of the person and how much ivermectin they need to stay safe. And a small donation from the proceeds of the book Catching the Worm will go to Sight Savers Ireland to support this great work. So it just remains for me to thank Bill and to thank Luke, and to remind everybody that Catching the Worm is available from the Royal Irish Academy website, ria.ie, and all good bookshops. And wish Bill a happy birthday again. happy birthday, Bill.
Well, it's been great to spend some time with you, Luke, and with you, Claire. It's just wonderful to see you, even remotely.
Will you come back to Ireland and visit us, Bill? Donegal's dying for you,
Well, I remind you, this is my 90th birthday.
Yeah.
But I certainly won't turn down any opportunities to come to Ireland.
Well, you're always welcome.
Open invitation.
Thank you very much.
Thank you.
I look forward to it.